Okay, this video explores solving two-step equations. So a two-step equation is, in fact, an equation in which we take a number, do two operations to it, and get a result. Which then, if we work backwards, requires us to undo those two operations to get back to where we started. So, a couple things we've been talking about in class with regard to solving two-step equations or solving equations in general is using inverses and using the golden rule. So again, inverses are opposite operations, so the inverse of add is subtract, and the inverse of multiply is divide. They're called inverses because they undo each other. Again, they are opposites, so it makes sense that they undo each other and sort of cancel each other. The golden rule is whatever you do on one side of an equation, you have to do to the other side of the equation. Again, because we talked about the fact an equation is like a balanced scale. So if you put something on one side, you have to put the equal amount on the other so that the scale maintains its balance. The balance is the fact that the equation is, in fact, equal. So we're going to do these couple examples here where it says, please solve the following equations. Again, solve means to determine the missing number that makes the equation true, and we will do that by applying the idea of inverses and using the golden rule. We will try and undo these equations to some extent, so we have to understand how they can be read in PEMDAS order going forward so that we can in fact go backwards to find the original number that is unknown. So if we notice here in this equation, it says 2x minus 7 equals 19. That means if we look in PEMDAS order that somebody took the number and multiplied it by 2, and then they subtracted 7. And this was the do order. The undo order, going backwards then, with the inverse operation, should be add and divide. So this is what we're going to look to do right here. So I see that here the subtract 7 in the equation can be undone by adding 7. They are inverses of each other. And then I need to apply the golden rule and do it to both sides so that the equation is still balanced. So then I will write down from left to right. So I pull down the 2x. Actually, let me do that in black so that the color is maintained. So 2x, negative 7 and positive 7 cancel because they are inverses. Pull down the equals, and 19 plus 7 is 26. So that checks off the add. Continuing to work up my mind map, I see I'm going to divide next, which makes sense because we see here that there's a multiplication by 2, so its inverse is division by 2. Also, a clever move will be to multiply by 1/2. I'm working from left to right. I see that 2 over 2 cancels, and then we get x, x equals 13. And this is my answer. You can check that on your calculator. I'm going to concentrate on just doing these examples to get the answers. You can feel free to check them using the store button on your graphing calculator. It's a very handy thing to do. Okay, in this next problem, we see in the mind map going forward in PEMDAS order, somebody took a number and divided it by 6. They divided it by 6. And then it seems like they added negative 4. We'll call that subtraction. We'll call that a minus 4. The sign associated with the 4 is negative, so we can call that minus. And then working backwards, we could see that I'll undo the minus with add and undo the divide with times. So I'm going to work in this map. So I see the minus 4. I'm going to add 4, which, again, I get the idea of inverses. And I'm going to add 4 to both sides to adhere to the golden rule. So working down from left to right, I get that that cancels. I pull down my b over 6. That equals 16. Check off the add in my mind map. Now I'm going to go to the times, which makes sense because I in fact have a division by 6. So it makes sense to undo that with its inverse operation of multiplying by 6. Inverses cancel as a matter of practice. We get b equals 6 times 16 is 96. So my answer is b equals 96. Again, it's the answer because 96 is the missing number that when plugged in for the variable would make this equation true. And you could plug that in if you like and get a chance to check it. Okay, in this next equation, we see it's negative 5 times the quantity y plus 1 equals negative 35. I'm trying to do this in two-step fashion. Later on, you're going to learn that we like to distribute in this situation, but let me actually just try and adhere to this fact that it's 2 steps. It looks like somebody added 1 and then multiplied by negative 5. And let me just try to focus on being consistent with what's in this video, although there is another way to do this problem. So we see here that somebody took a number and they added to it, and then they multiplied. And that is the do order. The undo algorithm, the undo method here would be to divide and then subtract. So solving going upwards here to go backwards, I would see here that I could divide both sides by negative 5. The writing here might look a little weird or not what you expected, but negative 5 on top will cancel this negative 5 on bottom, giving me y plus 1 equals negative 7. That checks off my division that I just did. And now I'll move forward and do my subtraction. So this says plus 1. So it makes sense that the inverse of that is minus 1. And working from left to right, again, I see that it's y equals 1 minus 1 cancels. And I will get negative 7 minus 1 is negative 8. So, oh, I'm sorry. I made a small mistake there. Just here, when I did the negative 35 divided by negative 5, I see that that actually should be positive 7. So let me use the domino effect here to adjust this, and I'm not going to get negative 7 minus 1. I'm going to get 7 minus 1, which in fact is 6. Sorry about that. You probably caught that right while I was doing the problem. And if I would have checked that answer of negative 8, it would have been wrong. And I can see here that 6 makes more sense for the y, because if I plugged it in, I would get 6 plus 1 is 7, times negative 5 is in fact negative 35. So, again, these two-step equations still work in the same way that one-step equations do, around the idea that you have to use inverses, which undo given operations, and use the golden rule, which means you have to do it on both sides. Sometimes I'll refer to that as doing it OBS, on both sides. So, it's very important that you are able to read in PEMDAS order and create these maps here that dictate what is being done to the problem, so you can create a reverse map to show what is being undone to work backwards. They're a little bit like do, undo, result type of problems. We're writing them very differently. We're writing them much more maturely. So this is a process that's going to help move us towards the 5-step method and away from the DUR method. So, but it is the writing that we are looking for here that needs to be important needs to be correct. So enjoy. Feel free to watch again if you'd like.